4.7 deals with linear inequalities. So we need to remember how to graph lines. So there are two forms that you usually have for lines. One is the form y equals mx plus b, and the other one is ax plus by equals c. Okay? And they're both really easy to graph. So if I had y equals 3x minus 4, how do we graph that? 3 is the slope, and that is the y-intercept. So we put a mark at -4, and 3 is 3 over 1. We always do rise over run. So we go up 3, 1, 2, 3, and over 1, and then that would be the line. You guys remember that? Okay, what if we had y equals -2/3 x plus 1? So same thing, up 1, and then the slope is -2 and over 3, and that would be the line. Okay? What if I had y equals 3? What does that line look like? Well, it's missing this, right? It's missing the slope, so it doesn't have any slope, which means it's just a horizontal line at 3, right? And if you look at this, no matter what point you pick, it's going to be something comma 3. So that line is every single y value that equals 3. So no matter what x is, y is 3. What if we had x equals -2? -2 where? So this one is going to be a vertical line at -2. And again, it doesn't matter what point you pick. Every single point on that line is -2 comma something. Okay? Has all of that come back? Okay. Now let's look at this type of equation. It's also pretty easy. So let's do 4x minus 3y equals 12. One way to graph this is to move things around and get it in slope-intercept form, y equals mx plus b. But there's a way easier way to do it. Okay, the easier way to do it is just to figure out when x equals 0, what does y equal? And when y equals 0, what does x equal? And all you have to do is get rid of the x and solve for y. When I delete the x, what does y equal? -4. So the y-intercept is -4. Okay, if I delete the y value, what does x equal? 3. Pretty easy, right? Okay, let's do another one. So 1/2 x plus 3y equals -6. Cover up the x. What does y equal? -2. Cover up the y. What does x equal? Close. -12. Right? Because x cut in half is -6. So x must be -12. I didn't think this through, did I? So here is the line. Okay, we good with graphing? Let's look at our assignment today. So, we have an inequality here. So, we could graph this, and we will in just a minute on a different set of problems, but it wants to know, is the point negative 3, 7 part of the solution? What do you think that means? So let's plug those in. 8 times negative 3 is negative 24. 3 times 7 is 21. Is negative 24 plus 21 less than or equal to negative 3? It's equal to, so yes. Oh, good. Okay, let's plug in negative 2, negative 5. So we're going to stick this in there and that in there. 8 times negative 2 is negative 16. 3 times negative 5 is negative 15. Is that less than or equal to negative 3? Definitely. Negative 31 is smaller than negative 3. Don't become a banker. Yeah. Okay. Negative 2, comma 0. Plug that in there, I get negative 16. Plug that in there, I get 0. Yes. Okay. And then 4, negative 6. That's 32. And that's negative 18. Is that less than or equal to negative 3? No. Now, here's the important thing today. What does that mean? Why did some points work and other points didn't work? Yeah, we need to graph it. So let's pretend that it's an equal sign, and let's graph it. So I cover the x. Cover the x. What does y equal? Negative 1. So my y value, my y-intercept is negative 1. Okay? Cover the y. What does x equal? Negative 3/8. So here's negative 1. So negative 3/8 would be right there. So here's the graph. Now you have to be careful. This says less than, but you can't trust that, because depending on where there are negatives, that thing might flip back and forth. So don't trust the inequality. Here's what you do. Pick a point that is really easy to plug in. What would the easiest point be to plug in? 1, 1 would be easy. 2, 2 would be easy. There's an easier one. 0, 0 would be the easiest. So I am going to consider this point right here. Okay? So if I plug in 0 plus 0, is 0 plus 0 less than or equal to negative 3? No. So this point is a no. What does that tell me? Well, let's try the other easy point. 1, 1. So plug in 1 and I get 8 plus 3 is less than or equal to negative 3. This point is a no. Let's plug in this one, 3, 0. 8 times 3 is 24 plus 0. Is that less than or equal to negative 3? That's a no. What do you notice? They're all no's. Why? Because they're all on the same side of the line. So if one point is a no, then all points on that side will also be no's, which also means all of the points on the other side must all be yeses. So we need to shade over here. And all of those points are yeses. Now let's check. Where is negative 3, 7? So negative 1, 2, 3, 7. That one was a yes. Let me switch colors. Okay. What about this one? Negative 2, negative 5. That one was a yes. Okay, this one, negative 2, 0. That was a yes. 4, negative 6. That one was a no. So when you're graphing a linear inequality, you graph the line, and then you check a number. 0, 0 usually works, but sometimes 0, 0 is a bad idea. And I'll show you why in just a little bit. And then when you test that number, it helps you figure out which way to shade. Yes? Yeah, you can. I'll show that in just a second. That's a good question. There's one more thing that we didn't look at. The equal to. And it was this one. I graphed that wrong. That is actually right here, because it was equal to. So we need some way to make that line the equivalent of an open circle or a closed circle. Does that make sense? Okay. So when we're graphing on a number line, a closed circle means equal to. Right. So if the inequality is equal to, then we draw a solid line, which means the line is a yes. If it's not equal to, then we draw a dashed or a dotted line, which means the line is not equal to. Okay, so let's look at number 2. Y is greater than negative 4. What is this line going to look like? So, is it going to be solid or dotted? Dotted, and you can... Yep. I don't know how to... Oh. There we go. How do I... Oh, and then this button will switch. See that? This button will switch from solid to dotted. Okay, and then we want to shade up, so I use this to touch the shading side. Like that. Okay? All right, for this one, so I need to draw my line. So this one touches the y-axis at negative 2, and then the slope is 5 over 1. So I go up 1, 2, 3, 4, 5, and over 1. And is this going to be solid or dotted? Solid. And then I need to check 0, 0. So 0, 0. Is 0 smaller than 0 minus 2? So is 0 smaller than 0 minus 2? Yes or no? No. It's saying, is 0 smaller than negative 2? No. So this point right here is a no, which means all of the points on the other side must be a yes. Oh, my mouse. I gotta click mouse. Okay. All right. Okay. How do we graph this one? Cover the x. What does y equal? 3. Cover the y. What does x equal? 2. Solid or dotted? Dotted. Okay. And what point do you want to try? Let's try 0, 0. So I plug in 0, 0. Is 0 plus 0 bigger than 6? No. So the top side is a no, which means the bottom side is a yes. Now, Hannah asked a really good question a minute ago. She said, how do you know if 0, 0 works or not? Well, what if our equation was y is less than 3x? How would I graph that? What's the y-intercept? 0. And the slope is 3. Okay. And this is dashed, right? Now, can I try 0, 0? Why not, Tyson? The line hits 0, 0. So I can't. Yeah, so 0, 0 isn't going to help me now because this is a dashed line, so 0, 0 is going to be false. But it doesn't tell you which side to shade. So whenever you plug a point in, it doesn't matter what the point is as long as it doesn't hit the line. So any point will work unless it's a point on the line. So what point should we choose? 1, 1 is a good one. And we can see that 1, 1 does not hit the line. Is 1 less than 3? Yes. So we shade this side over here. All right, let's look at number 6. Okay, now we need to build the equation. We have the graph. What is the equation? So this one's going to be y something something. What's the slope of this? 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. That simplifies down to. So I have a rise of 2 and I have a run of 8. 1/4 x. What's the y-intercept? Plus 2. And then what's my symbol going to be? What'd you say? I think you were right. Less than. Okay, it's not equal to. How do I know it's not equal to? It's dotted. Okay, and then look at 0, 0. Is 0 smaller than 0 plus 2? Yes, so we need to be down here, so it would be less than. Okay, let me make sure. I think that's all the problems, but let me look. Yeah. All right, get to work.